3.5 is talking about absolute value. Have we seen absolute value before? Maybe once or twice, hopefully. Okay, so what is absolute value? Anybody know? Branson? Yeah, perfect. So really, by definition, what absolute value is means it's distance from 0. We know that distance can never be negative. Can never be negative. So if I think about a number line, if I'm thinking about the way a number line works, something's distance from 0 is literally counting like the hops it takes to get there. So from -2 to 0, that's 2. From +2 to 0, that's 2, right? So whether the number is positive or negative, it should have the same distance from 0, and that distance should always be a positive number. So basically all we're doing is we are going to take that number, whatever's inside of the absolute value symbols, which are just these straight lines here, and we're going to take it and make it positive. So -6, the absolute value of -6 is 6. The absolute value of 11 is 11. The absolute value of 2, here's a shocker, it's 2. Ready for, go for it.
15.
Perfect. Simple enough there? The hard part comes now when we are going to solve equations that have absolute value symbols in them. So these equations now have x's in them. What we need to keep in mind are these 4 steps. You're going to want to star these or highlight them or whatever, because these are the 4 steps we're going to follow for every absolute value equation that we solve today and in the future. The first step is to isolate the absolute value expression. So that means I am going to have on one side of my equal sign the absolute value symbols, an equal sign, and then everything else. Once our absolute value symbols are isolated, then the next step is to write 2 separate equations . Something happened to my pen here. 2 separate equations that represent each possible answer. So if I think about this with an x in it, if I say that the absolute value of x equals 2, I have 2 possible solutions. What are they? James? X could be +2 or x could be -2. So that's what I'm saying when we have 2 possible solutions. One is going to be positive, one is going to be negative. Does that make sense? Okay. Once we split our equation into 2 possible cases, then we are going to solve each equation separately and check our answers at the end. Are we ready to see how this works? It's very simple. So take a look at letter A. The absolute value of x is 4. I have 2 possible cases. One is the positive version. X equals +4. Notice my absolute value symbol goes away. The only thing that changes is that absolute value symbol going away. Then I say x equals -4. Same thing, my absolute value symbol goes away, but now I make the second half of that equation negative. Is there anything else for me to solve here? Anything to move away from the x? No. So these are my 2 answers. Any questions on that? Okay, take a look at what happens here in letter B. I have t plus 5 equals 11. Number 1, my first step is to isolate that absolute value equation. Is my absolute value symbol isolated here? Is it by itself on the left side? There's nothing else on the left side except for that absolute value. So then I move to step 2, which is to separate this into 2 different equations. The first equation will literally just be the exact same, except I've gotten rid of the absolute value symbol. The second equation will be pretty much the exact same, except that 11 on the other side is now going to be negative 11. That's all I'm doing here. Now there is more for me to solve here. I have to go ahead and move that 5 to the other side so that I can get t by itself. So I'm going to go ahead and do each one of these individually. So minus 5 from both sides. So t equals 6. Or, oh, hello. T equals negative 16. Any questions on that? Okay, let's keep going. Here's letter C. What do I have to do first here? I got a minus 2. I got to get these by themselves. So I have to isolate these absolute value symbols. To do that, I'm subtracting 2 from both sides. 3x minus 3 equals 11 now. Now from here, now that my absolute value symbol is isolated, we're going to separate this into 2 different cases. The first one, I'm going to take that and leave it exactly the same, except for the absolute value symbols go away. And the second one, I take the absolute value symbols away and just make the other side negative. We got that? Let's finish it off by solving. We're going to solve each equation separately. Add 3. So 3x equals 14. Or x equals 14 over 3. Which doesn't come out very nicely, does it? And then on the other side, 3x equals negative 8. Or x equals negative 8 thirds. Any questions on that? Okay. What about letter D? What does my first step have to be in D? What's the first step? Anybody? Adriana? Perfect. Add 1 to each side. Some of us are getting confused on that quiz about order of operations. We want to make sure that we're still using backwards GEMDAS. So addition and subtraction have to come first. I'm still not isolated here. I still need to divide by 3. And then what? Now it's isolated. What do I need to do? Adriana, can you tell me what those 2 groups look like? One stays the same, and the other, the 8, becomes negative. Let's solve. Oh, I'm skipping steps here for sure. X equals 3. X equals negative 5. Sorry, I have to skip steps to make it fit in here. Questions on that? Okay, I got to show you E because E gets weird. Take a look. Same start. I need to get this isolated. So my first step should be subtract 6 from both sides. Oh, goodness. What is different about this equation as opposed to all the other ones we've done so far on this page? Jacob?
The answer is like already negative.
Yeah, on the other side of the equal sign, I have a negative number. I haven't had that before. Can an absolute value be equal to a negative number? Can I ever say the absolute value of something is -4? No. Absolute values can never be negative. So make this note right here. If the absolute value symbol is isolated, can I fit it in here? Isolated. And the answer is negative, what do we think we're going to write? How about no solution? The caveat here, the important thing that we are paying attention to in this little note is that the equation, the inequality, or not the inequality, the absolute value has to be already isolated. Okay? If I have other stuff next to it, like let's say I had an equation that looked like this. Let's say it was, I don't know, x plus 2 plus 8. No, not plus 8. Minus 8 equals -2. If I don't isolate my absolute value sign and I say, hey, I see a -2, I'm going to call that no solution. Is that going to be correct when I actually do the isolating? Because when I actually isolate this, I add the 8 here. And hey, look at that. Now x plus 2 equals +6. And that's totally fine. So we have to make sure that we isolate that absolute value first before we can say no solution. And if it's isolated and we still have a negative number, then it's no solution. Does that make sense? All right, flip it over. I want to do B and C, and I think we can skip A because I think that's too easy for us. Can I get 2 people? 1 for B, 1 for C. I saw Emma and I saw James first. Which one do you want? Beautiful. You got the other one? Yep. Amazing. Any questions about this? Do we feel like we kind of understand the steps here? Okay. All right, let's do the application and then I'll leave you be. The weird thing about these applications is that when we see applications like this for absolute value, I don't know what other kinds of absolute value applications you might see, but a lot of the times it's these distance and times problems. Okay, because absolute value, distance, always positive. They go hand in hand a lot. They love these problems on the ACT and like AP tests. So, starting from 100 feet away, your friend skates towards you and then passes by you. She skates at a constant speed of 20 feet per second. Her distance, d, from you in feet after t seconds is given by this absolute value equation. At what times is she 40 feet away from you? So you will probably see a question like this on your test on Monday, where the equation is already given to you. We don't have to write it ourselves. That's really nice. So let's rewrite this so that I can solve it. The important thing here, number 1, is that we know how to solve this. But number 2 is that we know what these variables do, because you're going to be asked to write your answer in a complete sentence. So let's kind of pick it apart. I have 2 variables here. I have d and t. What do they each represent? It's told to us in the problem, so it shouldn't be. We're not making anything up. But what are they? Adriana? Distance in what measurement? Perfect. So my question says, at what times is she 40 feet away from you? So which variable am I going to be solving for, D or T? T. It says at which times. So I know that I must have a distance. What's my distance that I can plug in? 40 feet. And that's going to be our distance here. So let's plug that in. And let's solve. So I know I'm going to split this into two cases. One positive, where I leave everything the same. And one negative, where I make that 40 negative. I'm going to have to skip some steps to solve this, but here we go. Subtract 100. Negative 60 equals negative 20t. Divide by negative 20. T is 3. On the other side, oh, hello. This is 7 is t. So I've got my t values. Can somebody tell me in like a sentence what that actually means, James? Perfect. At 3 and 7 seconds, she will be exactly 40 feet away from you. So at 2.99 seconds, she's not 40 feet away from you. At 7.01 seconds, she's not 40 feet away from you. But exactly at 3 and exactly at 7, she is 40 feet away. Any questions on that?